So this is the verbal explanation of the posted homework solution. For the first problem, we've done this in class. So we have the 11 kilometers east, 11 north. So you just form the right triangle and you calculate your displacement according to this formula here. And the distance instead is not a vector, so you just add all those steps up. So as you notice, your distance is bigger than the displacement, which makes sense. Also, remember that for displacement, you got to have a vector, which means you got to have magnitude and direction. So for direction, you have to do the tangent of your rise over run, and you will find the 45 degrees, which is north of east. For the second problem, you have those two forces applied at the same point, obviously, but to calculate the resultant, you still have to translate one of those two vectors. For example, you keep 125 and you translate 165, and then you solve for the resultant, or you keep 165 and you move up instead, 125. Obviously, the resultant has to be the same. So then you calculate magnitude and directions one more time with the rise over run, if this is the angle that you're choosing. If you're choosing this angle here, it's going to be this rise over run. Okay, then number 3 instead, so this is different because you have 13 east, 3 west, which gives you a total of 10 east, and then 18 north. Sorry about the clock. So at this point, you have horizontally 10 kilometers, vertically 18 kilometers. So your vector has component 10, 18. So at this point, with those two components of your vector, which is basically this 18 and this is 10, right? Then you can solve for magnitude and direction again. Distance instead is the sum of every single step that you have taken. So it's 13 plus 3 plus 18. So you don't go backward when you're counting the total distance. Then for number 4, you have still those two components of velocities. Those are two velocities. You got to, again, find the total resultant velocity by the usual formula according to the square root, and the angle, which is your rise over run, and the direction also is north of east. Next problem is, so this one for number 5 instead. You still have those two velocities to take care of. It doesn't matter if this is a river, if this is wind blowing with the airplane, whatever the problem is about, you still have two vectors to take care of, okay? And you got to calculate the component. So if you're having 120 and 45, obviously your, what is called the magnitude is going to be square root. Your angle instead, okay, you can choose the 120, okay, as a rise, like I'm writing here. 120 as a rise means this is 120 and it's phasing the angle. So this is your rise over run. So if you choose those two dimensions, okay, 120 divided by 45, then you're going to have this angle here, okay? And then you got to say also that you're moving from north toward east. So it's east from north. If instead you're choosing this angle here, okay, you got to do your rise over run, which is this one instead, and your angle is going to be 21, and it's going to be north of east, okay? Obviously, whichever you choose, the two together have to give you the 90 degrees anyway. The other, and again, you can choose whichever angle you want. The other problem, number 6, instead has three vectors. So choose one good way when those numbers are so big you cannot just count squares, is to solve by components, okay? So 165 is this, 130 is the angle, so you will have a cosine, which is your x component, and the sine, which is your y component. Then you have 185, which is straight east, so east and no vertical component. and the 195, the problem is giving you this angle here, 60. So if this is the angle 60, then this is going to be your x, which is the cosine, and this is going to be the minus sign, okay, because it's going down. Then when you add, you have a component that is positive, the y component, which is negative, which makes you go into the fourth quadrant, right? So if you're in the fourth quadrant, this is your picture basically. And at that point, you calculate your magnitude and you calculate your direction. So you know that it's here. So at this point, you have choices. Are you choosing this angle or this angle? Whichever you choose, you will do your rise over run. So if you're choosing this angle here, it's going to be this rise over this run. If you're choosing this angle here instead, you're going to have this rise over this run. So either you find the 11 degrees or you find the 90 minus 11 degrees, which is this one, okay? Then next problem. Okay. Next problem is this one. So for this, okay, we have, okay, the problem is talking about a river and the boat going in a direction, but basically you have two velocities. You have the velocity of the boat and the velocity of the river. Now those two velocities are going to combine in such a way that the boat at the end will move in a direction that is the resultant basically of those two velocities, right? So you have vector, you got to calculate your resultant with this is the magnitude and the direction is again rise over run. So in this case, this is the angle, right? For 8, same thing, you have two velocities, right? Both of them, I can write them applied at the same point, but then again, I got to translate one just like if it was a displacement situation. So you got to form your right triangle and you got to solve for magnitude and direction. Number 9, same thing, but here you have vectors that are given in weird angles. So those angles are always calculated starting from the x component. Now, what I like instead, because I am me, I like to do, so instead of calculating 215, which is the angle that goes from x all the way to here, I like to go for the smaller angle instead. So 215 is bigger than, what is 215 actually is this one, right? Because it's bigger than 180, but smaller than 270. So I'll take the whole 270, I remove the 180, okay, and I am left off the 180, whatever, I'm sorry. So the 270 is this. I remove the 215, okay, which is this one, so I have 55 left over, okay? So this is this angle here, okay, 270, so this is basically this angle here, okay? The whole 270 minus the 215, which is this. So I have this one left over. For the other angle instead, they say is 125. 125 is bigger than 90, but smaller than 180, so it has to be here. So I can do 180 minus 125, and I have this one as a 55. At this point, I have those two angles, so I can solve accordingly. You can do instead with the 215 if you're more comfortable with that. So for this one, nevertheless, you got to have exactly the same numbers that I have at the end, right? So this vector here, A, has a negative x component with the cosine and a positive y component with the sine. This one instead has a, so it goes negative for y with the cosine and negative with x with the sine. Okay, then you add them up and you find negative and positive, which means you're in the negative and positive, you're in the second quadrant. So identify your magnitude, identify your angle, and solve accordingly. Then your next one is So those problems are pretty easy, I think, at this point, because you have your vector and they ask you straightforward component for the x component, for the value of the x component, and that's the one, right? For 11, they say, okay, give me the two components, Vx and Vy. So Vx is negative, Vy is positive. Again, make sure that you identify which one is the angle. You can choose the 149, which is from here all the way to the vector, or you can choose the smallest one as a 31. It's up to you. 12 is identifying somebody pushing on a mower, I believe it was. And so if you're pushing, you're going in this direction, so toward the ground, right? So this is your angle, or you can say that this is your angle. Those are alternate angles. This is exactly the same thing. So x component at those different angles. Well, if you're going straight down on 60 degrees, you're almost vertical. So obviously the projection of your x component on the ground is kind of small. That's why you have a 36. Then you start instead bending the pushing the handle of the mower more and more horizontal. Therefore, the projection on the ground for the x component becomes bigger and bigger and bigger. So it makes sense that it increases the magnitude of the x component. Obviously, you will have a max of utilization of the force at 72 if you're pushing horizontally, but being a mower and pushing horizontal, you must be on the ground there. Crawling is kind of hard. 13, same type of situation. They give you the vector. You got to find east-west component, which means horizontal component, and the north-south component, which means vertical component, and you solve. Number 14, you have those three vectors. Again, the struggle is to identify the angles. Once you have those, you see that this one has a plus cosine plus sine for those two components. This one has a minus cosine plus sine, minus cosine plus sine. This one instead is a minus and minus, right? Minus and minus for the third vector. At that point, add them up, find the resultant, square, square, square root, and find the angle as well. Then 15, this is the first time that they are actually incorporating those forces, which is equilibrium. Well, equilibrium is anything. If I'm pushing with 15 toward east, if you want to stop me, you got to go with 15 toward west in such a way that those two forces cancel each other out. Magnitude has to be the same, direction has to be opposite. If you push stronger instead, I'm moving backward, so I'm not in equilibrium anyway. So if this is west, then you got to push east, whatever that is. 16, again, you have a vector and vector. You got to find the component, the resultant with a square, square, square root, and in tangent. Which one is the force that produces equilibrium? Again, has to be as big as this one, right? So it has, if you're pushing in that direction, 53 north of east, with 10, you got to push back still with 10, but instead of 53 north of east, you got to be in this direction, which is 53 south of west. This one, again, same type of problem, but those vectors are random. So it's better if you actually calculate, they give you the angles, right? So calculate those angles and those components. So this vector here is a component which goes with the cosine, positive. This one goes with the sine, positive. This one goes with the cosine for the y, positive, and the sine, positive for the x component, okay? So again, you find those components, add the square, square, square root, and find the angle. Forces that produce equilibrium is, well, again, the magnitude is 127, so yours has to have 127, and the angle has to be the one that if you draw this, this resultant here is going to be positive and positive, so it's going to be somewhere in the first quadrant, right? So if you do your rise over run, this is the angle that you're looking for, which is 48. 48 north of east, the resultant. So your force instead has to be in the opposite direction and has to be 48 south of west in the other direction. then a couple more. So this one, you still have again vectors, blah, blah, blah. So you got to solve accordingly. You have to find the magnitude and direction. And then for this one, you got to solve with the inclined plane. You have the inclined plane, you have the bulk over there, you have a force going straight down, you have perpendicular force and horizontal force. The perpendicular one is the one that has the angle included here, so the 66 degrees is right here. This is your vertical component going down. This is the parallel component going across, going along the plane. And those are your values. Then for number 20, you have still those problems, but guys, you're not going to have problems like this, 19, 20, 21, or 22, because those are extensively going to be discussed later on. Other than that, so I wrote specifically to not worry about those two problems, because again, it's something that you're nursing before it's too much to handle right now. So focus on tomorrow's test and good luck.